I've said that we use anti-differentiation by parts when we have a product in our integrand, but really any integrand can be rewritten as a product. Um, this is an integral of natural log of x, which is not one of the integrals we have memorized, but we can rewrite it as a product. Watch this magic, natural log of x times 1. There, now it's a product. And now it's a candidate for using anti-differentiation by parts. And so remember the steps for anti-differentiation by parts. The first thing we're going to do is find u using lipit. And for this example, we don't have to get very far in lipit before we see that we should use u as natural log of x because it has a log in it, which is the L in lipit. And everything else will be dv, which in this example is just 1. And then the next thing we do is we have u, so we're trying to find du, and we have dv, so we're going to find v. So to find du, we're going to take the derivative of natural log of x, which is 1 over x. And to find v, we're going to take the antiderivative of 1, which is x. Okay, and the next thing we do from there is we're going to use that formula. So the formula is u times v minus the integral of u dv. And so we'll do that. So u times v would be x times natural log of x minus the integral of u dv. So 1 over x times x dx. And look what happens here. It becomes something that we can integrate, something very simple that we can integrate. It's x times natural log of x minus the integral of 1 dx. And now we can do the antiderivative there, so we have x times natural log of x minus x, and then plus c at the end. Remember that the check would be prove to yourself that the derivative of x times natural log of x minus x plus c really does give you the integrand, which is natural log of x. And I hope that you are aware that that check will involve using the product rule, because what we're doing with anti-differentiation by parts is undoing the product rule. So I leave it to you to do that check, but it's always a good idea when you're learning a new skill to actually prove that it works. So that's what you should get if you take the derivative of the answer.